Hello, dear students and developers. Welcome to the Refinitiv developer community. This is going to be part 2 of our tutorial looking into estimating the USA monthly GDP figures via an expenditure approach in the Holt Winters model. Last time we looked at some of the theory and codebook, as well as the libraries that we're going to import to use in this investigation. But this time we're going to be going through some of the functions that were handmade, created here for this investigation. And instead of going through them one by one, which would be quite dry, I thought of actually going through more ergonomically. So we're going to start with some Python fundamentals, and then we're going to see how these functions actually came to be and why I ended up creating them instead of just programming things line by line. All right, without further ado, let's get to it. All right, so moving swiftly onwards, we're going to be going through what a Python function is. First of all, I'd like to just use some Markdown in order to anchor where we're at and make sure that I'm not getting lost in my code. Remember that we can use Markdown to show some information that's got a bit more than just raw text. For example, I'm using backslashes for delimiting a new line, or hashtag to show that I'm using a header. And now I'm going to go through what exactly is a function. Okay, so first of all, let's define what a object is. An object in Python can be pretty much just anything that is written in memory. So here, for example, I am writing in memory an object, a Python object called test, and I'm saying that it is the string t. And I do this because it's in inverted commas, and this string is just showing us the characters capital T, small e, small a. And in these inverted commas, we're just delimiting this string. Now, if you want to know what type of object you are working with at any one time in Python, you can use the native Python function type. Okay, so here, for example, I am defining the Python object test as the string t. Let's have a look at what this is. It says it's an str. Str is just short for string. Okay, so now we can actually use functions with our objects. We've already done so with type, but here, for example, we can use print. Print just outputs the information put in memory for the object that you put in. Here, for example, we used the object test, which, if you remember, was defined as t, and therefore it prints t. The reason it's print is just a legacy thing. Back in the day, computers didn't actually have monitors. They'd have to print things on paper, and it was just chosen to be kept with Python. You don't have to use specified objects inside of all functions. You know, the argument here, test, doesn't have to be an object. It can just be straightforward the thing that you want to use. For example, here, if I use the same Python native function print with the actual string itself t and run this, you'll see that it just prints it correctly. Okay, we've been talking an awful lot about strings, and there's something interesting with strings, which is that you can concatenate them. For example, if I have 9 plus 1 here with the inverted commas, instead of giving you something that you might expect, such as 10, it's actually going to give you 91, and that's a string. The reason it does that is because it's added the 1 onto the 9 as if it was a string so that it concatenated them. That means that most of the time, if not all the time, strings cannot go through mathematical functions. For example, the plus here kind of worked because it's defined in Python for strings as a concatenation. But here in this example, when I do negative or minus, it's just going to run into an error because you can't just subtract the string 1 from 9. It'd be the same as saying subtract A from B. There's no logic behind there unless you were to define what A and B are as numbers. Instead, therefore, you can just use straight up numbers. Numbers that are just round in Python are called integers. And here, for example, doing 9 minus 1 gives you 8. And you can specify if you want something other than an integer. So for example, let's have a look. Here, if we have 9, we see that is an integer, but say that you want 9.0 or 0.01, then that's a float. And I'd like to speak quickly about what a float is. A float is a Python object that delimitates an integer where in the memory for that object, for that Python object, there is a space dedicated simply just for the decimal place. So as a result, it's not an integer anymore. It is what we call a float or a floating point number. And so, for example, if I was to type something like this, float 1, instead of giving me the integer 1, it's going to give me 1.0, just to show you the 0.0 here so that it's actually identifying and expressing the decimal place. This is of importance for later stages in our investigation. Okay, next I'd like to quickly explain how one may try and define their own functions in Python, as opposed to using, for example, print. Print shows you something, or type. Type gives you the type of the object that you've used as your argument. By the way, here, for example, in type 9.01, the argument is 9.01. Well, I'd like to explain how one may go through making their own Python function. To do so, we use the def uh, grammar, if you want, the def Python grammar. And this starts with saying def space. And then from then on, Python knows that you're defining a function. And I'm trying to create a function named add_1. So I do so this way, and I use the argument within the function I'm creating, number. And what I'd like to do with this number is I would like to print out, so return, this specific number plus 1. The way you do this is simply just with this colon and then the tab. So if you see here, there's a tab to delimitate that we are now within the realm of the definition of the function add1. Okay, so if I was to run this, it doesn't do anything because all I've done is I've defined this function. But now, let me just exemplify how this function would play about. There you go. So here the argument used within my add1 function is number, and I've defined that argument as 8. So now it's taken number and it's printed it out with plus 1. So it's printed out 9. Okay, moving swiftly onwards. Now we can have a look at getting to our harder coding. Okay. Using Markdown, I'm just showing that I'm going through some headers. So we're getting to the coding. We're going to look at monthly data. And here you can see that I'm using square brackets and round brackets to create a hyperlink. And here, if we press like this, we can see that my third heading, USA's consumption data, is a link. When I click on it, it sends me to my Datastream portal. There we can have a look after entering our credentials, the data in question. Okay, let's have a look at how we may come about collecting data. We've done it before, but I just want to remind you how we've done so. And here, for example, we've created the Python object called data, and we've inputted in there the table of data that we were looking for. So let's have a look at what we've got. All right, so here we've got the consumption data for the US on the 15th of every month. If you see NaN, that means it's not a number. If you see NA, normally that's not applicable. They're similar in their concepts. If you're trying to find things within your data frame that is not NaN, there's a simple way when using a pandas data frame like this one that we're using here that is outputted by Datastream. We can just do .drop NA, and that will just remove all of the NaNs, and you're left with only the columns that have data in it. Okay, moving swiftly onwards, we can have a look at some other functions that go in tandem with pandas data frames. Now, you may be wondering why I keep talking about pandas data frames. Well, this thing here is a pandas data frame. You see, Refinitiv's Datastream API returns pandas data frames, which can be verified this way. We're using the pandas library, and it's returning this data frame. And with this data frame, we can use a function, which is the .iloc function. Simply use your data frame and then .iloc with square brackets and the row number for the element of which you're looking for. So here, for example, it's going to give me the 200th row of my pandas data frame. And in there, we can see that the instrument is our consumption data. The field is X, which is to say the default for Datastream. So it is in US dollars, and this is our value in question. Note that it is a float. It's a float number, just like the floating point number that we've been speaking about before. The other such Python function that I'd like us to go through is the .index one. In Python, it's interesting to note that when using pandas data frames, the row names are defined as indices. So if you do data.index, it's actually going to return each of the row names in your data frame. So you see here we go from 1950 to 2020, and the data type here is object. Now that's important. We're going to be switching from date time objects, that's what this specific object is, and string objects back and forth, and you'll see why right here. Okay, so the first 8 characters of our index are just the year and the month. But what I'd like to do is normalize all of our data so that it looks like it all came from the 1st of the month, because in this instance, we have data that comes in on the 15th of the month. But sometimes, for example, for the quarterly data that's going to be coming up, it won't be specifically on the 15th of the month. What if it's on the 30th or the 1st? Well, then I'd like to just normalize everything and make sure that that last piece here that says 15 actually says 01. So it will look like it's from the 1st of the month every month. To do so, we are defining our data index as what we'd like. And here we're looking at our original data index that we can see above, and we are changing the type from this object to a string. The reason we're doing this is so that we can then use this function here. So everything from there to there is just here to allow us to use this function right there, slice replace. What slice replace does is that it goes to the character, the nth character defined here, so the 8th character in this respect, and replaces it with what you've defined right there. And remember that in Python, especially in pandas, things are usually 0 indexed. So let's have a look here. If I'm looking for the 8th character, it will be the 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be looking at this 1 right there, and it's going to change that character 1 into the first character to be replaced with the 0 right there. And then after the 1, it's going to be going onwards and say, okay, the next character is 5, and here I have more than one character that I'd like to replace. It is going to replace that 5 with a 1. And this is what this cell is going to be doing. If we have a look at our index now, we can see that it all changed to the 1st of the month. We can set this up programmatically, you see. If we were trying to define a function with our arguments, which would be our data and our data name, we can change the day of the month that the data appears to have arrived in our data frame. And we can then switch back from these strings that we've created here, that we've changed, to the date time object that pandas is used to. The only reason you need to do this is because many, if not all, of pandas functions assume that the indices are that kind of object. Lastly, but surely, we're also going to change the column name simply just by saying data.column equals and then data name inside a list. At the bottom, you can see here that it says return data. And so we're just going to return the object that we've called data this whole time. If we run this, then we have put into memory our function called translate to 1st of the month, which uses the arguments data and data name. Once we've done all this, we might actually want to keep all of the data that we're going to collect together into one data frame as opposed to just overriding the Python object called data. To do so, we can use the pandas.merge function. I'm not going to go through too much of the specificities within this function, but instead what we can do is just run it and see how now we've created a data frame with the data name defined as an argument within the function that we've created ourselves here. Translate to 1st of the month, which we've defined up there. And here it is. Now, if we do this again and use pandas.merge with another data frame, a data frame other than the one we've defined right there, df equals pandas data frame with an empty list. This empty list means it's an empty data frame. We've merged it with our data frame here above to create our data frame right there. Okay. If we want to do this programmatically again, we can create a function to do so. Now, this is just going to make things looking an awful lot neater in the future because we won't have to use all of these lines of code in order to do what we want to do. And here what we can do is use the global df, so the predefined object called df here, which I have defined previously before defining the function add to df, as a pandas data frame with an empty list. So it's an empty pandas data frame. And I'm going to translate to the 1st of the month, so use the function we've previously defined, the data that we've got from Datastream, and call it ds_data_monthly. So now we're looking at monthly data that looks like it's the 1st of the month. And we can merge anything that comes out of this object with the previously defined Python pandas data frame. Okay, so if I was to run this, it's going to keep this function in memory so that I can then use it below. Here you see that we are using our defined function add to df with the two arguments data and data name. Our data name here is a string describing the data that we're using, which is consumption here. And the data that we're using will be data from Datastream for our consumption. Running this, we can then have a look at our data frame, and we see that we have programmatically set up functions to go through the work in one go in one function right here instead of doing it manually. All right, this was a shorter video in order to just go through the fundamentals of how to create functions and how this is going to be useful in the next steps coming up. In the next part of this tutorial, we're going to be looking at our quarterly data sets and how we can merge all of our data into one so that we can go on with our investigation. All right, thank you very much for watching, and I'll see you in the next one.